The following presentation is about hyperbolas. The shape comes from slicing a cone with a vertical plane. A hyperbola is a set of points in a plane such that the absolute value of the difference between the distance from point P to two fixed points, F1 and F2, is constant. So what that means is we have the distance from here to here, and then the distance, and if we subtract the distance from here to here, we're going to end up with a constant. There are two equations for hyperbolas. The first equation is x minus h squared over a squared minus, so the way this is different from an ellipse is there's a subtraction sign in between the two terms, y minus k squared over b squared equals 1. Finding the center, the focal points, and the vertices and the covertices are the exact same as the ellipse, but hyperbolas are going to have asymptotes. The equation for the asymptotes are going to be y minus the y value from the center plus or minus the slope of this line is going to be b over a times x minus h, the x term from the center. And the following shapes are going to look like what's seen below here. It's two parabolas facing opposite directions with the two asymptotes that cross through the center. The vertices touch the hyperbolas and the covertices do not. To get a vertical hyperbola, we'll have the y squared term as the positive. So this time y minus k over b squared comes first, and then we subtract out x minus h squared over a. But then finding the center, the focal points, the vertices, covertices, and the asymptotes are the exact same. The only difference is it's going to open up and down instead of side to side. To calculate the c value for a hyperbola, it's c squared equals a squared plus b squared. In this situation, the c value is going to be longer than both the a and the b value. Hyperbolas have transverse axes, which is the distance between the two vertices. So if it's a horizontal hyperbola, the transverse axis is going to be horizontal. If it's a vertical hyperbola, the transverse axis is going to be vertical. And the conjugate axis is the distance between the covertices, so going the opposite perpendicular direction. Write the equation and create a graph for a hyperbola given the foci at -1, 2, and 5, 2, and the vertices at 0, 2, and 4, 2. The first thing you're going to want to do is you're going to want to draw a sketch. So here's the two focal points. Sorry, the focal points are in green, and the vertices are in black. If we sketch in a hyperbola, the focal points are always on the inside. It opens towards the focal points. So in this situation, we have ourselves a horizontal hyperbola because the transverse axis that connects the two, coming this way, is horizontal. The center is going to be halfway between the two vertices. So our center point is going to be somewhere around here. To calculate that, we use the midpoint formula. Add the two x values together, divide by 2. Add the two y values together, divide by 2, and we get our center at 2, 2. The a value is the distance from the center to the vertices. So the a value is going to be from here, center, to the vertices. So this is a. And if we count, we start at 2, end at 4. That's going to give us an a value of 2. And then the c value is going to be the distance from the center to the focal point. And in this situation, the c value is going to be equal to 3. We still need to calculate the b value, so we're going to use the equation c squared equals a squared plus b squared. When we fill in the pieces and solve for b, we get b equals the square root of 5. So our final equation is going to be x minus 2 squared over 4 minus y minus 2 squared over 5, and we have our x term is first because it's a horizontal parabola. Hyperbola, sorry. Okay, so we have x minus 2 over 4 and y minus 2 over 5. We have the focal points and center already. We still need to figure out where the covertices are. The covertices, we are going to add and subtract the b value to k. So our b value is radical 5, so we have 2 comma 2 plus or minus radical 5. So our two covertices are at 2 comma negative 0.2 and 2 comma 4.2. The asymptotes, y minus k equals plus or minus b over a, x minus h. Fill in all the pieces, so here's our equation for our asymptote. Y minus 2 equals plus or minus radical 5 over 2 times x minus 2. Plot all of your points first. So here were the points we had before, the center, the focal points, and the vertices. We need to add in the covertices. And what we're going to do next is we are going to draw a square around the vertices. And what this square does is it helps us draw our asymptotes, because our asymptotes are going to have this point, a rise of radical 5, and a run of 2. So all you have to do for your asymptotes is draw diagonal lines that go through the corners. And then lastly, we need the shape of our hyperbola. And make sure you don't touch the asymptotes. Graph 4x squared minus 3y squared plus 8x plus 12y plus 16 equals 0. The first thing we're going to do is we're going to rearrange our terms, grouping the x's together and grouping the y's together, and moving the constant to the other side. We're going to factor out a 4 from the x terms because the 4 is the coefficient in front of the x squared. And then we're going to factor out a negative 3. When we factor out a negative 3, it's going to change the sign of the middle term. So you see how we started off with a positive 12? We're going to, when we factor out negative 3, we end up with negative 4. And then we need to add 4 times 1 over here to the other side of the equation, and negative 3 times 4 to the right side of the equation. Remember that that 3 is negative. And then we keep solving, factoring, dividing by negative 24. Our final equation is y minus 2 squared over 8 minus x plus 1 squared over 6 equals 1. Our b value is going to be the square root of 8, so that's 2.8. Our a value is going to be the square root of 6, 2.4. And our c value is going to be the square root of 14, which is 3.7. We already have the center. It's negative 1, comma 2. The reason why it's negative 1 is because the x term comes first, and then the y term. It's a vertical hyperbola because the y term is positive. So when we find the vertices, we are going to add b to the k value. So we get negative 1, comma 4.6 and negative 1, comma 0, negative 0.6. To find the focal points, you always add to the same number. So we're dealing with the k value here, so we're adding c to the k value. And then for the covertices, h plus or minus a. And our asymptotes are going to be y minus 2 plus or minus 1.1. I got 1.1 from taking b over a. times x plus 1. Plot all your points first. Make your rectangle that goes around the co-vertices and the vertices. Your asymptote's going to cross through the diagonals. And then since we have a vertical hyperbola, it's going to open up and down. And remember, your focal point always needs to be inside of your hyperbola.